back into the recording service. Okay, cool. Can everyone see my screen?
Yeah, I can see.
Cool.
Yep.
Yeah, so we talked in the last few weeks about lenses, and specifically I was showing kind of, partial lenses and the idea of using getters and setters with advanced types of lenses to do manipulations of data and making it kind of really easy to read and write from complex data structures and do some pretty fancy things. I want to show sort of a more practical way of how you'd use that in a library like React using hooks. So, how can we use that same concept of lensing, but use it in data that we're going to pass around between components in a stateful kind of way? So what I have here is just like a boilerplate React app that doesn't really do anything. And I have a useLens file where I'm going to write the useLens hook that we can then use in this app to create this kind of stateful piece of data that we can manipulate with a partial lens. Just so you can see the dependencies, we've got React loaded in, of course, and then the partial lenses library, which we're going to use for our implementation. Okay, so let's get started with the lens. So we're going to export a function here that's going to be called useLens. And let me just zoom in a bit. useLens is what we're going to use to create a lens where we're going to be able to map or get the data and set the data and even create new lenses. So our lens is going to have some sort of format like this. It's going to have kind of a get function, get method for getting data based on a lens. It's going to have a set method for setting data based on a lens and value. As part of the set, we want to make sure that other entities listening to this data using this lens are updated. So we want a way to sort of notify things that we have new data, since lenses, when you set them, just returns an immutable data structure, like it returns a new data set. So we need a way to kind of do that. So we're going to implement, sort of add a callback mechanism for data changes that we can then use to hook into React stuff. And finally, we're going to implement a method called ProMap, which we're going to use to create new lenses from existing lenses. So the ProMap method is basically going to take a function that has like a new getter and a new setter and returns for you kind of like another lens that's kind of a subset of the existing lens. So we'll be able to take like a lens that's maybe looking at a giant piece of state and create sub-lenses that are narrowed in on smaller pieces of that tree. So to use the lens, we'll need to provide some initial data structures, sort of our initial state. So I'll just call this like init state. And I need to keep track of this data and how it changes over time, which will be obvious as we sort of create the lens. So I'm going to use React state hook and just initialize it with this initial state that gets passed in. We have the state getting kept here through renders as part of our hook. We have the ability to update that. Now we need to create a lens, and the trick is we're going to want that lens to be stateful, and I'll show what that'll look like in a second. But first, let's kind of do this piece of just creating the lens. So I'm going to create a function called createLens, and the createLens is going to take really 4 inputs based on our descriptions below. We need it to take some sort of getter, so we're going to call this the get lens. Some sort of setter, we'll call that the set lens. The data that it should be using for the getting and setting, sort of like that's like our initial data. And then, as we mentioned here, we're going to want a callback to be used for data changes. So we're just going to create a callback kind of on set. So those are our 4 parameters to create a lens. Now the return of this is pretty simple for the first couple of methods. So the get method is really easy, right? The get method, it's just going to take a, we'll call this kind of like a lens that's coming in, and it's going to use the partial lenses library, and do a get. What it's going to do is it's going to compose kind of the outer lens, like the parent lens that we have here, with whatever this new sub lens is coming in. So a person can take a lens that's focused on one part of the data and then lens it even further when they get something. So they'll compose these together, and then the data is the data that the parent lens is sort of keeping track of. The set is going to be very similar with an extra complication of the callback. So we're going to have, in this case, a lens to set on and a value that we're going to set to. And what we know is that if we use l.set, it's going to give us back a new form of the data. So we'll do l.set, and just like before, we're going to do the composition. So we'll say whatever kind of the parent-defined lens is, we'll use that. And then we'll also add in, kind of compose in whatever lens is provided at time that the method's called. And we'll use this new value, and we'll use the existing data. Now this call is going to mutate this, not mutate really, it's going to produce a new data set with the changes, and so we'll get that back in a value, and we'll ultimately want to return that in case the person that calls us wants to do something with it. But we also, as we said below, we need sort of a callback mechanism for data changes because we're going to ultimately use this in some hook that needs to update state of React components that other components can get that state update. So this is what we'll call onset. We'll just say onset with the new data, and so onset can be whatever function we want to plug in there. So this is fairly generic from like, you know, what the React implementation is. Nothing about this has anything to do with React yet. We'll just use onset to plug in the React piece of it. The last piece then is ProMap. So if I want to create a new lens from this existing lens, what I would have is really two inputs. One is like, I'll call this the sub get lens, and the second one I'll call this the subset lens, which is that we're going to take our existing lenses and we're going to add more lenses on them, sort of more paths to get a new lens. So in this case, since I'm getting a new lens, I'm actually going to call the same function that this is being invoked in. I'm going to create a new lens like this. And now the trick here is that, you know, I'm going to use the same data and we're going to keep the same onset. We're not going to really change that at the child levels. But what I do need to do now is change what my lenses for getting and setting are going to be. And so what I can do is kind of compose this parent hierarchy by just composing like the parent lens with the new sub lens like this. So I'll say use the original get lens from above and then add in the next kind of sub lens that we're asking to be mapped to. And the same with the setting side of things. So that's what it means when it says ProMap. That's what it means. It's a ProMap is a form of like bi-mapping where you have mapping in two directions, two maps. In this case, the first one is going in the getting direction, and the other one's going in the setting direction. So we'll compose this way. So we get this nice ProMap function. And so we have a function now for creating lenses, and it more or less meets our contract that we sort of outlined in this thing right here. So we have some state that's being kind of initialized with whatever data the user passes in when they call use lens. But now what I want to do is I really want to create a lens based on that state. And that lens needs to change because we can see that, well, if we ProMap, we might produce a new lens, but also when we set the data, then we're going to want to have a new lens reflecting that data set. So what I can do, and I'm not sure this is the optimal way to do it with hooks, but this is one way that will work because I was playing with this earlier, so we'll do this for now, and there may be better ways to do it. Is I'm going to create a piece of state for my lens. And I'm going to initialize it as just like kind of a lens with kind of top of the house for the getter, top of the house for the setter. The initial data will just be the initial state. And then we won't really have like a callback yet for onset. So that'll give me the just kind of empty lens that doesn't do anything. But what I really, and also I want to return this lens so others can consume that lens and get with it and set in ProMap with it. Now the trick here is that when I set something with it, I'm changing the data, which means the data that this lens has at that parent level is no longer really the data that I want to be working with. So what I want to do is actually update the lens with a new lens whenever the data gets set. So that's where this onset is going to come in handy. What I can do is I can use the useEffect hook and basically say, when the state changes, go ahead and create a new lens with the new state. So I'll say set lens, and we're going to set lens to a new create lens, and that lens will have an empty getter, an empty setter, but now the data for the lens is going to be the new state. And there's one missing piece, which is, okay, what should it do when the state changes then, when that data changes? What it should actually do is just set the data state up here. So basically what we're doing is we're creating a lens where it has this piece of state as the data, and when I change the data using something like set, I want to call set state with that new data. That'll update this kind of piece of state inside the hook, which will then cause the lens to update. And that's really it. That's the whole thing. It may not be intuitive what we're going to do with this yet, so let's do some examples. Let's go into the app here. What I can do now is I can import my lens from my use lens hook from that use lens place. I have this basic app. So maybe I create a lens using use lens with kind of my initial state. In my initial state, maybe it has this like foo property, but maybe it also has this like deeply nested kind of z property, something like this. Or maybe let's make this like hello. How about that, a string, so we can work with the string. So there's the lens, and there's a few different things I can do with it. The first thing I can do is just a simple get, so I could change this to like lens.get, foo, and there's kind of the value sitting there. Which is fine, that's how things would consume the lens. Not super interesting, but what if I had child components that wanted to both kind of read and write from this data coming from the parent application? The easiest way to do that was like, let's take this hello property, for example, and let's add a lens to that location in the parent. We'll do X, Y, Z. You'll see there we have, take the console down here. We've got, well, let me annotate this. So let's say I wanted a child component to both be able to read from this value and write back to it, and have any other component reading from this lens kind of leverage that. Well, let's create a new component that's going to take in the lens then. We're going to make something called myInput, and that's going to take a lens. And what that's going to do with that lens is return an input object. Let's go ahead and put the input object in here. Sorry, myInput. And for now, we won't even set a lens because we don't need one yet. There's an input. Doesn't really do anything. You can just kind of write in it and things like that. But let's say I want this input to affect this kind of XYZ property. Well, this is where ProMap is going to come into handy. Because what I can do is I can create a new lens that I'm going to pass to this input. So I'll say the Z lens is equal to my lens.ProMap. And now ProMap takes a kind of a sub-getter and a sub-setter. So the sub-getters that I want it to focus on X, Y, and Z. And my setter is actually also the same. Like, I just want to make sure I'm updating the Z properties. It's going to be the same in this case. There are reasons you'd have it different, and I'll show an example in a minute. Okay, so now I have this Z lens, and if I actually come up here and change this to just like zlens.get, now you're going to get the same kind of result of hello still sitting there. What I can do now is I can pass this lens to the Z lens to my input. And in my input, I can now map it to that lens's value. So I could say, well, the value should be lens.get this guy, right? So there's the value there. I can't change it, though, because that's just a piece of state, right? Well, to change it now, what I can do is just implement my onChange handler and say, take the event and do a lens.set. And set just the entire thing to that event's target value. And I missed a curly brace. There we go. Okay, so the value is gotten from the lens, and the onChange event is the setter of the lens. Now what I have is anything I type in here is getting written to that parent state and consumed that way. What's kind of cool is then if I want to like keep adding to this, like, I could do one for foo. If I had like lens.promap, foo. So I could change kind of any property this way. So I could write any kind of component to receive this lens, through the hierarchy or through through context, if you wanted to use that concept in React to do some cross-cutting stuff, and easily kind of read and write from it, and everything's going to kind of get that same value because it's going through this stateful lens right here. Now, what's really kind of interesting then is I can start to leverage some of the power that partial lenses has when I'm doing the pro mapping. So for example, we talked last time about, you can do transformations in lenses. So what there was a rule that I had here as a user where I was like, well, for this, or for the business, where like in this logic, the value should never be stored with capitals. So like, this is not valid. We always want the string to be like in a lowercase value. What I could do for this lens that could get passed around to multiple places to get edited by multiple components is I can just actually add a rewrite lens to the setter side of the pro map. What rewrite does is it basically runs a transformation anytime you do a set, anytime you write through that lens. So I can say, okay, on write, take whatever value you're trying to write and map it to lowercase. Didn't do that right. Let's see. L is not defined. Oops, forgot to import the library. Star as L from partial. Okay, so now I have my caps lock key on here, but everything's coming through in lowercase. Or even to prove that point out, I'll copy and paste some text that has uppercase in it. And when I paste it in here, it's going to be converted to lowercase. Right? So I can do some sort of like implement some fairly like complex or strict logic around how this data is accepted and actually stored back into the state without components downhill or downstream rather needing to like have that logic baked in. Similarly, you could do things like we showed last time where it's like, oh, if this property is like is undefined, then it should just get removed. I'll show you an example of what that would look like. Let's say, I'm not sure if this will work, but I'll try it. I didn't test this feature out. We could do something like, let's make this into a single lens. Z lens optic. Lens and optic mean the same thing, so this kind of nomenclature is a little weird, but let's say we want X, we want Y, we want Z. On rewrite, we want to do this whole thing. And what we want to do is say if the value is undefined there, then say not defined. And finally, we want to make this whole thing removable. So we want to say if Z is not defined, then like Y isn't defined, then X isn't defined. Realizing I don't have a way to make it undefined. Oh, I have an idea actually. Okay, so I could say it's like L.removable Z. As an example, let's just do that one first and see if we can remove the Z. And we're going to make the rewrite a little more complicated. We're going to say const new s equals s.to lowercase if s.length greater than 0, return new s, else return undefined. So basically saying like if they put an empty string in there, remove the the Z property. And finally, I'm going to change the pro map here to use this like more complex lens. So basically, my goal here is to say, hey, if they type text in here, make it lowercase. And if they don't have any text written in there, then just like remove the Z property completely. And if it's removed completely, then the value that should be provided instead should be explicit text saying like, hey, this isn't defined. So this is still working, and if I come down here, it got changed to being not defined. So I can't actually make it an empty value ever. It's impossible to make it an empty value. I could make it a single string or something else, but I basically made it so it can't do that. have an empty value, nor can the user type in capitalization, although you can see that the value or will override that and kind of put its capitalization in there. So kind of an example, a cool example of kind of the power of lenses and what they're capable of. And so, you know, again, this is kind of a stateful lens now that could be passed down to any kind of child components or through React context and things like that. So anyone can consume this and get from it, set from it, create their own kind of sub-lenses that focus on a particular part of the tree with specific logic. So that's the idea there. I'll share this code. I'll make this kind of a public link you can look at. Any questions about what I've shown?
You did that so fast. That was impressive.
That was good.
I did do a practice run before this. Yeah. And in the practice run, I did screw up this implementation. And I'm not totally proud of this implementation either. I think there's probably like better ways to do this than this kind of like snaky, like, oh, you have state here and then you set it here, which then causes this to fire. I'm not in love with this, but for a quick, you know, hey, 20 minutes or less, how we set this up, you know, it proves the point of how you could accomplish it. Any questions on the phone?
Is there any difference here with use effect versus use context or anything like that, or is this?
Was the question? You're a little faint. Was the question? There's a difference between use effect and use context?
Yeah, in this scenario, is that, or I mean, is this is just a global piece of state, effectively, right?
It's not. And so that would be the difference. I mean, use effect is just used to like kind of get this get the state updating based on get the lens state to update based on the data state. But really, this piece of state isn't global. It's like exists at the context of its parent component and anything you pass down from there. So if there were a component above the app, it wouldn't have access to this. Now, if you wanted to leverage it in sort of a global way, in that like you wanted any component in the tree to be able to leverage this single lens, like you almost like a piece of global state, then that's where context would come into play. So essentially, you could, again, I'll be doing this off the top of my head, so I'll probably get it wrong. You could import something like create context from React. You could create a context, I'll call this my state. And what I could do is essentially create this lens here and then deliver the lens as a value that the whole app gets. So I could say my state context dot provider, and the value is equal to the lens. Make sure this still works. Yeah, still works so far. But now instead of like passing down this logic this way, maybe we sort of take all this out and just let's change this back to like lens.get xy. And let's say my input doesn't take like the lens itself anymore. Maybe it just takes like the optic definition or the lens definition. I'll call it lens def. How about that? And so what I'm going to do is I'm going to put back up here, like, here's my, I'll call it the Z lens def or something. Now what my input could do is say, okay, well, it's getting in kind of the Z lens definition, or sorry, a lens definition that it should use, but it's going to pull the lens off of context instead of out of the app parent tree. So what it could do is say, okay, well, then the lens that I want to use is going to be from the context called my state context. And instead of getting, and then we'll promap that. So then we'll say kind of like the local lens or something like that equals lens.promap, lens def, and we'll say this is local lens, this is local lens, and this ends up being And now it works the same way. And now the difference is that like this component doesn't need to be past the lens directly. It can just pull it off of context, which means you could have some like deeply nested component, like, you know, function, you know, we'll call this kind of middle component that is going to return, you know, now I have this middle component, right? App itself is very simple, right? It has the single lens that gets going to get passed down to every component in the app, potentially via context this way. But there's no reference to kind of like the Z lens anywhere below that. And then I have this middle component, which does not receive any lens from it. But inside the middle component, it calls the myInput component with some definition of how it wants it to read the input. And then the myInput component is able, from very deeply in the tree, you know, from like 3 levels down, to pick off that lens from the state and then work with it there. And we get the same net effect, where the lens at the top of the house is still being affected by this myInput component that was kind of at the bottom receiving that. So that's how you would use context to sort of pass this around to anything you wanted to. So in essence, sort of creating this global state provider that has some kind of strict rules around how it works. Does that make sense, Justin?
Yeah, I mean, that basically gives you a little slice of state to work with anywhere you want. This is a lot like Redux, right, at this point. You've got your global app-wide lens.
Right. Yeah, Redux is just like a way, right. Redux is like a way to handle global state via context, right? It's like a pattern, or with the implementation of a pattern. So this is another way to exactly to do that. I mean, you can do that with context doing anything. You could create all kinds of different ways of setters and getters for like a context. So absolutely, yeah. Then you can pass the state around and do whatever you want with it. In this case, the point is like, oh, using partial lenses to do those manipulations.
Right. No, I like that because you can map pretty much from anywhere. Put a little wrapper around the presentation component, and then define exactly what the rules are for those pieces.
Yeah, exactly. Exactly. And I mean, there's room to expand this, right? Like right now, our onSetter callback just like keeps the state kind of fresh. But you might say like, oh, maybe I want the user to also be able to run side effects with this. Like, oh, when the state changes, I don't know, it needs to like send the new state also to a server for syncing or something like that. You could like, you know, also add like a custom, you know, user-defined like, you know, onset and kind of let them apply their own functions, and then you have something where like not only can you change state locally, but you can also cause side effects and things like that. So there's all kinds of cool things you can do by sort of wrapping this. And by the way, this is a very simple implementation of wrapping the partial lens. If you remember that partial lenses library has like more than just get and set. It has, let's get down to the set piece. Has .modify, .remove, there's .transform. There's all kinds of like operations you can take with partial lenses. So I didn't implement this here as an example, but you could just as easily also do something like implement a wraparound modify or transform, etc. The only thing you have to make sure of is that when you do that, you want to make sure you get the new data back and get it to update on the state. Otherwise, like, you know, none of this would work the way we've just shown it to work. So this is just one idea for wrapping it that I found useful in some projects I've been doing. Any other questions?
So I'm a little confused as to what exactly like the ProMap is doing or how it's working.
Sure. So if you think about, maybe the easiest way is to sort of like log out like what each lens is showing. So if I take this lens, I just log out like what data is it showing at the top of the house, where the empty bracket is just like an empty path, right? So it's just like the top of the house. this is what it's showing. So foo, var, x, y, z. So basically the entire data structure we passed in. What the ProMap is doing is it's creating a new lens that focuses on a subset of that data. So I could say like sublens or something like that. In the ProMap, it basically, you tell it like where do you want to map to when you're getting and where do you want to map to when you're setting. So for getting, maybe I want to map to x, and for the setting, I want to map to x as well. If I log out the sublens.get, you can see it's focused on like a subset of the data, right? There, like it doesn't have the foo property in there. So it allows you to create sort of it's sort of like a selector for your state tree.
Yeah.
Like using the, sorry, go ahead.
I was gonna say no. That certainly makes sense. I think I was thinking them as like different state or like data objects, but it makes sense that one's just a more specific lens on the overall context.
Exactly. Exactly. So it's always going to be in sync with like the whole parent object. What the use case here is then you can use like all kinds of like partial lenses utilities to do more complex logic. Like I showed the rewrite to make sure it's always lowercase, and I showed how you could like remove the z property and replace it with the default if they didn't type anything in, which would be useful for something like maybe like a click expression where you want to make sure it's not empty. Maybe it has like a default like equals null or something like that if they leave it empty. But you can also do weird stuff. Like you could make this. I don't know why you would do this. I mean, there are
this too. Like, what if these are different?
Yeah, well, and they were different in one of the examples we did where we only mapped to X, Y, Z on one side, but on the other side we mapped to like rewrite and all this stuff like that.
Right.
If they're different, what it means is that when you're getting on this side is going to look different than like what you're actually setting, and there's not really a problem with that. So technically I could take this and like, if I look at sublens.get, it's going to say just, it gives me X, Y, and Z. But if I try to change that, here, we could do a really weird example. Let's actually pass that into this guy right here. So let's change this to be the zlens def right now. Let's just comment this right here and say, okay, instead of pro-mapping it the way we did here, let's pro-map it such that we have the lens def for the X, the getter, so it's going to get me the actual hello property XYZ. But then let's change the setter to just be foo instead.
Okay.
Now what's going to happen, it's going to be very strange, is that here's the text hello, and there's the text for foo up there, but as I change it, it's only going to write that data to that one location. See what's happening there?
Yeah.
I mean, in this, because this use case is obviously nonsensical, it doesn't really make sense. But a use case which makes a little more sense when you're doing something like that might be, like we showed an example a few weeks ago with lenses and profunctors where we were doing mappings between like Celsius and Fahrenheit, where like the data was in one format in one location, like stored in the data set in one location, but we needed it in a different format in another location. I gave you, so degrees would be a good example where like make this like temp, and maybe the temp is like, 20, and that's like in Celsius. And we really want to like display the temperature in Celsius, but like then convert it to Fahrenheit. Probably, I don't know if any of you remember the formula. It's something like, so if we were converting from Celsius to Fahrenheit, it's like times 5 over 9 or something like that, plus 32, times 9 over 5 plus 32. Okay. So you take the temperature and you would do like T times 9 divided by 5 plus 32 or something like that. And so if I were to display this right here, I'll just do this, temp. It didn't work. It's not using the sublens. Let's use the sublens. Right. Still didn't work. What am I doing wrong? Sublens. Oh, it's already mapped to temp. I don't need to get it. Stupid. Okay. So, when I read this, I want to, map it to 68 degrees Fahrenheit, right?
Mm-hmm.
But if I make an input for this thing, so if I make, And let's say lens depth equals. Sorry, this code is becoming a mess, but you guys get the point. What I don't want to do is like have this get written, sorry, I don't want to write this directly to temp as Fahrenheit. I want to write it as Celsius. So what I really want to do is I want to do something in the opposite direction, which is when it gets written, I want to convert it back to Celsius. So I guess it would be T minus 32 divided by, or times 5 divided by 9 or something like that.
Mm-hmm.
And so if I just can't keep it this way, now if I make this like, you'll see that it's always displaying in Fahrenheit, and the text here is in Fahrenheit, and I can enter Fahrenheit. But if you look at what's getting logged in the console, the temperature is in Celsius. And so if I change this to 100, that's like 37.7 degrees Celsius. So you can create this kind of weird mappings where, like, I mean, in this case, I put it all in one lens because this is kind of how the implementation ended up looking. But you could have done that like up here by writing that rewrite, you know, right there or something. That'd be one use case for having a different setter from the getter. It's like if you need to transform them differently depending on what direction you're interacting with them. Or you could have the setter like override, like you could have the getter like display like some sub-property, but maybe for the setter you want to like set the entire object around it for some reason. I mean, there's all kinds of use cases like that you could end up doing.
Right.
Cool. Any other questions?
Another thing actually I noticed too was like so this input box is just always like in state with whatever the state of the data is.
Yes.
Because you're setting the value. Is that sort of enforcing that because it's like re-rendering every update?
Yes. So
I guess I expected when I saw you type in value, I would have expected you could at least change that initial value and like continue to like type into an input box.
what do you mean? Like I am changing the value when I do this?
Right, but like before you were setting you added like that setter, it wasn't allowing you to change, was it? Because it was continuing to read.
No, like I mean, if like I don't have the onChange event.
Right.
Yeah, I mean that's how. So like when you do, it's more of a question around controlled versus uncontrolled components in React.
Yeah.
So like I mean by default an HTML component is uncontrolled, right? Like an input box just like decides what it is going to render and what that value is going to be, and then to get the value out, you have to kind of ask it like what's your value,
Mm-hmm.
maybe add an event listener, things like that. But often in React we want to have what's called a controlled component where we want to be managing the state of that data going in there, and we also want to collect the user input from it to like update it itself.
Right.
That's usually the use case is kind of what we're shown here, where it's like, all right, well, whatever someone types in there, I actually need to store in state somewhere else for other components to leverage, right? I'm going to capture that input for other parts of my tree to use. So to make it controlled, you switch to telling it explicitly, like, here's how it should define its value. The problem you do that then, though, is you can't change the value because, like, React is controlling what the value is now.
Right.
So to complete the loop there, you have to say, okay, well, when someone tries to change the value, then I need to update that React state so this is what causes that whole loop to happen, because this sets a new value on our lens. If you recall in our lens, it says, you know, when it gets set, set this state. When this state changes, publish a new lens. So it causes this whole kind of cycle to happen where now you get a new lens down here with a re-render that has new data available in it. So that's kind of how the loop gets completed.
Yep.
Make sense?
Yeah.
Cool. Any other questions? Cool. I will clean up this code because I did kind of on the fly some things that made it a little more complicated, and I will share it. Let me stop the recording.